Okay, today what we're going to go through is just a slight continuation off of the integration that we did last week, and we're going to continue in another direction here. Now, the first thing that I want you to know with this is please do not think that this is it. This is not as easy as it comes. I'm giving you kind of the best of the best, the rainbows and butterflies, the best situations that there are. There are many, 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 many other ways of doing what we are doing. All right, there's integration by parts. There is integration involving sine, cosine, tangent. There's a whole bunch of stuff that I just don't want to waste time in going into. I'm going to give you the basics of the basics to let you roll with it. All right, this is not going to be something that is going to count for a calculus credit. All right, when you're taking your stuff in calc, you're going to learn all kinds of other stuff, use substitution, integration by parts, all kinds of crazy stuff. But just realize that this is not the end-all be-all. There's more to go. Okay? But what I want to start with is one indefinite integral that's a little bit tougher to do. All right? Integral of 1 over t dt. Okay? Now, it seems on its face that this is not too difficult, but it actually gets a little bit trickier. All right? So, 1 over t, well, that's the same thing as t to the negative 1. So, integral of t to the negative 1 dt. If I go through and solve in the same exact way that I had before, I would have, well, negative 1 plus 1 is t to the 0, and I take and I divide by my new exponent. Well, first of all, as soon as you have a 0 on the bottom here, that makes whatever you had undefined. If it's undefined, it does not exist. Therefore, we can't have this. Now, it turns out if you have a situation like this, this is going to spit out a stock answer. No work involved. As soon as you have this here, integral of 1 over t dt, it's going to be ln of t plus a constant. All right, it's just like a stock answer. Don't worry about it. Don't worry about how it happens. Just know that it happens. Okay, as soon as you have the integral of this value right here, it is always going to turn into that. Okay, so that is the last part that we're going to worry about with integration involving indefinite integrals. Now what we're going to do is we're going to look at how to do the math when we're looking over a certain portion of a curve. So before we had done the integral of, let's just do x dx. Okay? Now, when we had done this before, it was, well, you take the exponent 1 plus 1, x squared, 1/2 x squared plus c. Okay? This is an indefinite integral. The reason it's called an indefinite integral is it literally is not defined. Right? It is not defined where we are talking about. Right? Now, the nice thing about definite integrals is they tell you where we're talking about. So, let's talk about the same exact thing, x dx, but let's go from the range of 1 to 2. Okay? So, what I'm going to do here, I'm going to shrink off some, I'll just move on to the next page here, it'll be easier. Integration over here stays exactly the same. The only thing that's going to change now is we don't have that c value. Now we're going to have 1/2 x squared, and I'm going to move it over to a bracket here, 1 to 2. Now, what I'm going to do here is I'm looking at the range of what's going on from 1 to 2. So, we're going to look at final minus initial. So, that means 1/2 of the final. This is my final. This is where I'm ending. 1/2 of minus my initial. One half of 2 squared. Well, 2 squared is 4. Half of 4 is 2. Minus 1 squared is 1. Half of 1 is 1/2. So, one and a half is it. I'm just taking each endpoint and putting it together. We are not splitting the atom here. Not incredibly difficult. Okay? Now, this eliminates the fact that we need a constant at the end, because we're literally looking at these exact points. We know exactly where we're going. We don't have anything else to factor in here. Okay? So, not insanely difficult, but it's still going to have its own little tricks to it. Now, we'll do a couple of practice problems with these. I'll give you a couple with defined endpoints. Then we'll talk about what that C value means. Okay? This is the last one that is pure math. Starting with the next video lesson is going to start talking about why I'm talking about this. In the first chapter, we talked about derivatives because literally velocity was the derivative of x with respect to time. In the next video lesson, we're going to talk about why we're worried about integrals in terms of work. Work equals the integral of f dx. Now we're going to talk about what that means, all that lovely stuff, because not all the time. Last year in class, this force was always a constant. That's not going to happen in real life. If you're talking about something like a spring, if you're talking about any type of a real life situation, it's very rare that that force stays absolutely constant the entire time. So because of that, we have to look at it in terms of that changing force over the distance. All right? So try out the practice problems. They are on the assignments tab. Best of luck to you, and please try to get those practice problems to me by end of day Thursday. Thank you and good luck.